Ow! Why'd you do that? A question we find ourselves asking all the time, but a fair question at that. So let's break down what happened. You can see my exact position as I move on the scooter. You can also determine my speed with just a few calculations. The same thing goes for when I was stopped by an outside force. Then my speed changed, but you can still see my exact location. Nice, isn't it? We have to remember that our physical world goes much deeper than that. Here lies the quantum world. The quantum world deals with the parts of life that are much smaller than an atom. These particles, however, behave quite differently than normal. But what is not normal? This begins with Heisenberg's uncertainty principle. Heisenberg's uncertainty principle states that the position and speed of a particle cannot be known with perfect accuracy simultaneously. The more we know about a particle's position or momentum, the less we know about the other. Shining light on a particle can reveal more about its position, but it also causes its momentum or speed to change. So although we now know more about where it is, we know less about how fast it's going. Now let's make it make sense. Welcome to my lab. To demonstrate how light impacts particles, I'm going to be using my friend Marie Curie and our sense of hearing instead of sight, along with this mini car contraption I made that makes noise when it moves.
To conduct this experiment, I performed 3 trials. 2 trials consisted of misses, and the last was a hit on the target.
In the first 2 trials, I missed the target, knowing its speed is 0 but not knowing its position. In the third trial, I was able to find its position through the noise it made, but its speed changed because of the impact. By eliminating the use of sight from the physical world, we could better envision the quantum world and Heisenberg's uncertainty principle.
Oh, so that's why you threw a ball at me.
Exactly. And you were certainly the perfect demonstration of how the quantum world does not work.